And I am now recording. Today is April 5th, 2018. This is the regularly scheduled meeting of ITSE 2309 at Preston Ridge Campus, Collin College. This recording is available on Canvas under the module Recorded Lectures. Okay. Today we will be in module, let's see, we're going to be in module 10 today. And let me back up here. I've gotten out of page 5. Going to the modules. Okay. We're going to skip over module 9 for the moment. So the last one we had was module 8, subqueries, and that I have not graded those exercises yet, so they are due. I'll try to get to grading them tomorrow. Skipping over module 9, data manipulation, and I haven't turned on my overhead yet, have I? Okay, I will right now. Skipping over module 9, because we did that back in module 3. It was covered in module 3, so we're going to skip it for now. We're running a little behind. So we get to data types, chapter 8. And I've talked a little bit about the integer data type. We've been discussing that as we go along, and I believe I mentioned that all integers, no matter how they are represented, whether electronically, mechanically, whatever, they have a finite number of bits assigned to them. Therefore, they have an absolute upper bound. And if an integer gets too large, it will do what we call overflow, and it behaves kind of like the speedometer of an old 5-digit speedometer, the odometer, which when you hit 99,999 miles would reset, some people say, to 0. That's not exactly true. What happens is it carries out of range, so that 100,000's position is still there, but I just don't have enough digits to represent it. So it carries off on the high side of it. And it looks to you as if it's 0. In fact, it does go back to 0. So it runs out. We call that overflow when that happens. Lots of times when you have a signed number, because you have positive and negative, there's no such thing as if you put your car in reverse, you don't get -1 showing on your odometer. What you would get is 99,999 if it behaves like I expect it to. Lots of times what happens is that the joke, I believe I mentioned it last time, what state is farthest east? And we take guesses at it. It's a trick question because the farthest east state is Alaska. And why is Alaska the farthest east? Because it extends into the eastern hemisphere. So therefore, if I go as far west as I can go, and I take one more step, I'm as far east as I can go. The same thing is true with integers. When you get as large as you can get, and you take one more step, you add 1 to it, you are now as negative as you can get. Lots of interesting things about that, and we don't really have time to go into it. It's not really important if you take my programming class, particularly if you take my assembly language class. We will go into that in all of its gory detail, but I don't think I'm going to do it here. Does the integer have to represent both positive and negative, or is it just a number? Some things, for example, how far is it to the nearest star would be a positive number. If the star's on the other side of the Earth, does it become negative? No, it's just a distance from the center of the Earth to the star. So it doesn't have to be negative. I talk a little bit about this right here, signed integers, unsigned. I recommend some reading on that if you're going into computer science. This is a good video So you might want to take a look at that video. I'm going to defer that to the video and let you look at it. Integer data types are just plain int. We will usually use plain int. It is 4 bytes. In 4 bytes, I have how many bits? How many bits in 1 byte? 8. What do you say? 8. How many bits then in 4 bytes? 32. So since each bit can be either a 0 or 1, it has 2 possible values. That gives us 2 to the 32nd power different values that I can represent. Don't forget that 0 is one of those. How about how many is that? Well, let's see, about how many is 2 to the, did I say up there? And yes, 2,147,483,647 different positive numbers and negative numbers. Notice there's negative numbers. There's one more negative number than there are positive numbers. And this is because to a computer scientist, a 0 is considered it isn't a positive number. That would be wrong, but it is a non-negative number. So it gets counted with the positives. So they're negative or they are non-negative. So 0 counts as a non-negative. Therefore, because 0 is not negative, there's only one way to represent 0. That's 0. Then it's counted in with the positive numbers. So there'll always be one fewer positive numbers than there are negative numbers. The other thing is, if you want to get an idea of how many, think of 2 to the 10th power. Do we know how big that is? 2 to the 10th power. 1 kilobyte. What number is that? 2, 4, 8, 16, 32. What comes next? 64. 128. Next. 256. 512. And 10 would be 1024. Drop off the 24, and that, as a rule of thumb, that is, just call that 1,000. It's actually 1024, but we tend to think of it as 1,000. 10 bits. Well, if I have 2 to the 10th power of those, what do I have? 1,000 thousands. That's what? 1,000,000. If I have 2 to the 10th power of those, I have 1,000 millions, and that's a billion. Billion, yeah, 9 zeros. Okay, so that's 2 to the 30th power. We have roughly a billion, and then 2 more bits. That's 2 to the 2nd power of those. 2 to the 2nd power. 4. Oh, come on. 4, no, 4, 2 to the 2nd power, 2 to the 32nd power. 2 to the 30th power is a billion. 2 to the 2nd power is 4. 1 billion times 4 is 4 billion. Now, add those numbers up and tell me if that's not pretty close to 4 billion, if you're willing to ignore 250 million as being not really important. Just 250 million. Okay, close enough. So we think of it about 4 billion. If I just throw out an integer, if I say it's an int, I've got roughly 4 billion different values. 2 billion positive, 2 billion negative. Now, for most of the stuff that you do, an integer will be fine. If it gets really, really big, I can allocate, instead of 4 bytes, I can allocate 8 bytes. I didn't just make it twice the magnitude, I made it twice the magnitude 8 more times. 32 more times. I'll get that right in a minute, okay? So I've gone up from 4 bytes to 8 bytes, and from 32 bytes to 64 bytes. I have doubled it 32 more times. That's a pretty good sized number. I don't even know what the names of those numbers are. They're so big, okay? I wouldn't even want to try to read that number. Let's see, there's the thousands, the millions, the billions, the trillions, the quadrillions, the quintillions, and I believe that would be 9 septillion. That's okay. I had to look at it too. Some things we don't really care about one way or the other. Some things will always stay pretty small. A small int will give you numbers up to about 37,000 or so. 32,000, okay? So roughly 32,000, think of it. Okay, so that's 2 to the 15th power. Go ahead.
I started to ask why it has 2 to the 31st power. You can explain just taking the negative.
Right. There are 32 byte bits associated with that number. So that would be 2 to the 32nd power. But since it has positive and negative, we have 2 to the 31st power positive and, well, 2 to the 31st power negative numbers and 2 to the 31st power minus 1 positive numbers because 0 is in there. So we have 2 to the 31st power negative and 2 to the 31st power non-negative is the way I like to say it. But the negative numbers will always have one more than positive because of 0. It typically doesn't make any difference, except you need to bear that in mind if you're doing anything where it matters. So negative 2 to the 15th power to negative 2 to the 15th power minus 1. And then we have tiny int. Now, tiny int's a real little bitty tiny thing. It's 1 byte. Now, SQL proper does not provide a Boolean data type. What is a Boolean data type? True or false. SQL doesn't give that to you. You have no such thing as Boolean. If you go into Access, you'll see it. Some others do it, but basically it's just a 1 byte integer that the allowable values are it's either 0 or it's 1. Well, we don't need to do Boolean. We have tiny int. That's a 1 byte. If it's 0, it's false. If it's not 0, it's true, and that's the way we can deal with it. So we can create one. So our Boolean values in SQL are typically tiny int. Moved up, we double each time. 1, double to 2, double to 4, double to 8. And in theory, we could just keep on doubling and we could come up with an integer. For my dissertation, I was working in cryptography, and I developed an integer data type that was any arbitrary length. So if I wanted an integer that had 1,000 bytes in it, I could, or 1,024 bytes. That's a pretty darn big number. And in cryptography, you use those. Anyway, all integers will overflow. I put it down there in red. Anytime I put it in red, integer overflow. Overflow is the error you get in integers. Everything else in an integer is perfect. If you do integer division, if you say 7 divided by 2, your answer in integers is 3 remainder 1, not 3.5, 3 remainder 1. That is a perfect. Anything with a fixed decimal is an integer. Money has a fixed decimal. I will never store money as $17.23 or 17 23/100 dollars if you like. The reason for it is 1 penny will not terminate in base 2. 1 penny is 1/100th of a dollar. If I try to carry that out and get a terminating binary number, binary decimal isn't exactly right. Decimal speaks to base 10, so a number with a binary point, it will never terminate. Even though 1 penny, 0.01 is fine in base 10. The problem with it is in base 10, you have a factor of 5. Anything that is not a perfect power of 2 will not terminate in base 2. So 1/100th, 2 times 2 times 5 times 5, it has a factor of 5, it cannot terminate. Therefore, we will always have, I'm going to get to floating point here in just a minute, but I will never store a number as 17 23/100 dollars. I will always store it as 1,723 cents. I don't care where you put that decimal point. If you put that decimal point and you fix that decimal point, I'm going to turn it into an integer. I'm going to shift that decimal point out, store it as an integer, and then when I show it to you, I'll put the decimal point back in. Okay? Anytime we fix the decimal point, it is an integer. Let's look, here's the summary down here. Integers are limited by the number of bytes allocated. Anytime we fix the decimal point, it's an integer. All integers will overflow. Overflow is a carry out of range. And I say that is a test question. What is overflow? Well, you overflow an integer when you get too big to represent the integer. Therefore, the integer keeps getting bigger and bigger and bigger, and it grows on the left side of the integer, right? So 99, what's the next one? 100. So it's gotten bigger and bigger and bigger, and then 1,000, excuse me, 999, it grows up to 1,000, and so on like that. When you finally get to the end of the range that you can represent, it carries out of range. And you're seeing all zeros. That's all it can represent. So it actually becomes 0. Okay. Go next. Floating point. Here I'm talking about base 10 and whether they terminate or not. So for example, 1/2 terminates, 1/3 does not, 1/4 terminates, 1/5 terminates, 1/6 does not, 7 does not, 8 does, 9 does not, 10 does. And this is in base 10. But in base 2, the only thing that terminates is 1/2, 1/4, 1/8, 1/6, not 1, but anything that has a 2, 4, 8, 16, 32. If it has a power of 2 in the denominator, then it terminates. If not, it doesn't terminate. So if you talk about 110, one thin dime, that will never terminate in base 2. That gives us a problem. Floating point will not terminate in binary because it has a factor of 5. It's not a factor of the base. Floating point numbers suffer from, there's the other word I want you to have in your vocabulary, underflow. Underflow. What is overflow? Overflow is a carry on the high side, carries out of range. Underflow is a tiny little error on the right-hand side of it. It's a loss of precision. It says that my number is too big to represent, so I underflow. I flow off of the right side, off of the low side of the number, off of the far right side of the decimal point. I get it something way out there that's too far out to represent, so I just chop it off. At some point, for example, consider 1/3 as a decimal. What is 1/3 as a decimal? Well, that's 0.333333333, and then you draw a bar over it. But we can't do that in computer science. So at some point it comes to, it runs out of memory and it says, okay, that's it, chop. That's an error, a very small error. There was an early Gemini rocket orbital shot. It was I think the third one where they did several orbits. And they had one of these errors in it that every time that they did a calculation, they lost a little bit. When all they did was go up in space one time and come right back down, everything was fine. When they went for one orbit, everything was fine. But when this guy stayed up there, a day or two, the error accumulated, and the poor guy didn't even come down the right ocean. It made a big difference. Have you ever seen the movie Office Space? That's an example of that error. Their scam there of accumulating. So it's a cumulative error. Which one's worse, the really big error or the really little bitty tiny insignificant error? You want the big error, because if my program dies, I want it to fall down. Okay, that little insignificant error is going to be there every time. The big error, when that happens, you'll see it. When the little error happens, well, they happen every time. They happen every time you do a division. So the name of the game is you don't do floating point division. You do integer division and accumulate your remainders and then do the division. And then when you just have one remainder, if you just do it one time, well, you're going to get an underflow. But if I'm only off by 1/10 billionth of a penny, I don't really care about it. It's when I'm off by a 10 billionth of a penny, a trillion times a second, that I have a problem. Overflow is drastic. Here's my summary. Overflow is a drastic error on the high side. Underflow is an insidious error that's so tiny it's not considered important, and maybe it's not once, but they have a habit of accumulating. Overflow doesn't happen often. When it does, it's obvious. Underflow happens on almost every floating point calculation and tends to add up over the long run. So there's a point. Never use a float unless there's absolutely no way around it. Okay. We have never used float. We have used the number data type. Remember, we have used when I declare a field or a variable, any kind of a variable, as type numeric, and in some platforms it says number. In Oracle, it's number or numeric. I don't know. I think Oracle will take it either way. What am I declaring there? I say I have a number, and I have 10 digits, base 10. 3 of these digits are always to the right of the decimal point. I fixed that decimal. What kind of a number do I have? That's an integer. Okay. 10 digits, that's, we can be, it has enough memory to show at least 10 digits. I happen to know it will be allocated in base 2, so it's probably quite a bit bigger than that. But I'm safe with 10 digits if I stay under 10 digits. Counting the decimal. So that's 7 to the left of the decimal point, 3 to the right in base 10. So it's big enough to take that. Questions? Since it's a fixed decimal, it's going to become an integer. If I just say that, there is no decimal, so it's fixed. Now, unfortunately, if I say that, if I just say numeric, now I've got a floating point. Okay, I never use that. Float, this is the one I don't like. Don't like floating point. Stay away from them at all costs. Don't have anybody with us online. Okay, what else? Let's go back to our module. Floating point takes 8 bytes. You will see this in sometimes you will see this guy instead of float. Let me get it back up there. Sometimes you will see him written as real. In other programming languages, instead of float, they use real. In SQL, that has been depreciated. The correct way to say it is float. Most platforms will take it either way, but float is the new standard. That's a floating point. We don't like those. Okay. Character data, we have talked about this in pretty much detail. I want you to understand that there are 2 basic kinds of character data. There is char data, where in the parentheses tells you how big to make it, how many characters to allocate. This is essentially an array of characters. If I say char 10, it gives me 10 characters. It will always use 10 characters. If I put in fewer than 10 characters, it pads it out with spaces. If I put in more than 10 characters, I get, for my reading pleasure, an error message. Okay. The other one is varchar. variable length characters. If I say, and I will use varchar when it's fairly large. By fairly large, I mean at least several hundred characters. Although we have been practicing with it on thing like varchar 32, I wouldn't bother with varchar for 32 characters. Some people will call it varchar. You'll hear it either way. Go ahead.
I guess current understanding is variable character.
Variable length characters, yes.
Wouldn't only use 32.
Well, there's good and there's bad about both of them. A fixed size always uses 32 characters, and because of this, you will get some wasted space, some what we call internal fragmentation. Whereas varchar, if you only put 10 characters in there, it shrinks down to 10 characters, but it does so at a cost. Nothing is free in this business. So whether to use one or the other depends. If I have something that is very large, by very large, I mean 256 characters or so, and I will have wide difference in how many characters I put in there. So I'm putting in something like instructions to a doctor about a patient, and I don't know how much they're going to put in there. So I'm going to make it big. I'm going to give them 1,000 characters, 1,024. I like it on powers of 2. And I don't, but they probably won't use it all. They'll probably just write a little snippet in there, and that's, in that case, I would use varchar. A person's name, what's the longest a person's name can be? Let's say 16 characters. If your name's longer than 16 characters, you're probably used to having it chopped off. So, well, I mean, okay, 32. I'm willing to take the extra spaces that it puts in there just to avoid having to shrink and make it grow and shrink. So in general, if it's under 50, go char, over 50, varchar.
So would it be incorrect to say, hey, you have car 10, and I put in, I guess, the word happy?
Yeah.
I thought it had to be exactly 10 characters.
No, I'm sorry. You did. You did. I didn't. I guess I just didn't make that clear when I said it. It always occupies 10 characters. If you put in happy, HAPPY, that's 5. Then it will pad it out with 5 spaces. So the value of that, the value stored in that field will be HAPPY space 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 space. If you put in something that is 11 characters, you will get an error. With varchar, if you put in 11 characters and that it's too big, it will chop off your input, but it won't give you an error. So there's good things and bad things about both of them. Okay, the other thing, so we have fixed length, variable length. The other thing is that we have, it came as a shock to those of us in the United States that there are other languages besides English. I don't, that's what I said. I don't know why people can't, but I better be careful what I say here. I'm being sarcastic, of course, but with char and varchar, we are talking about straight ASCII code. And the other one is in char and in varchar. With in char and in varchar, each character is twice as big. So instead of 8 bits, each character is now 16 bits, which gives us 37,000 different values that we can use. So we can have all the full range of any kind of alphabet that you can support. This is the equivalent. Have you ever heard the term rich text? This is what rich text is. Rich text is a 16-bit character, allowing you to do lots of different stuff with it. So rich text, I would use rich text when I don't know to what word processor I'm writing. You can, that's because they can, with the 16-bit character, I can do a whole lot more than I can with an 8. So if I'm in Notepad, I only have one font. I have to take it or leave it. Well, I can change the font that I look at it in, but bottom line, it's just text. No. Notepad is straight text.
No, I mean, rich text is where you open up all your fonts.
Rich text gives you the ability to open up all your fonts. Now, Microsoft Word is really a compressed XML document. It's not really a document at all. So they're in a whole different world. They're compressed and everything else. If you have a small document, rich text will actually be smaller than a Word docx. Once you get very big, once you get 15 or 20 pages, that Word document is going to be significantly smaller than rich text. I just thought there. Anyway, nchar and nvarchar is essentially putting rich text into your database. I suggest that in this day and age, unless you know for sure that you're going to be in English and only in English, that you use nchar and nvarchar, because they will still represent English the same way. But they give you the flexibility later. The cost, of course, is your field is twice as big. Everything has a cost. So in practice, let's say anything under 64 characters is small. I would agree with that. Comes with an operational overhead. Isn't worth taking that overhead to save a couple of bytes. One more little issue here. Can I have a name that doesn't have any characters in it? What's my name? Well, my name is Steven, S-T-E-V-E-N. Well, what if I shortened it to Steve, S-T-E-V-E? Well, what if I just said S? Okay, what if I shorten it even further? And now I don't have any characters at all in my name. Do I have a name? Well, if a tree fell in the forest and, well, it comes down into that kind of a discussion. If I don't have any characters, do I have a name? Yep. The answer to that is a string of 0 length is not null. A string of 0 length and null are two different things. Okay? A string of 0 length is quote, quote, with nothing in between them. Null is N-U-L-L, not in quotes. Don't put null in quotes, otherwise you get the string N-U-L-L. So null is nothing. A string with no characters in it is a perfectly valid string with no characters in it. Okay? And this is a problem because I have to check if I'm working with a character field. I can check to see if it is not null. But what about somebody trying to give me the string with no characters in it for a name? So I can check for that. And so we have a character field last name, and assume I want everybody to have one. So here would be the constraint last name null, check. Last name is not null. Everything's cool there, just a plain old null, not null constraint. Next line, and I usually do them right together, constraint, last name 0 length, check, len, the length, last name is greater than 0. Let's see, I believe in this chapter we do the character manipulators.
So there's going to be at least one character in the last.
You have to have at least one character. So it can't be null, and it has to have at least one character. Because if I tried to check, I'm not sure what I would get if I said check that the length was greater than 0 and it was null, I'm not sure what would happen. So I always write it as 2 constraints. First constraint says check that it's not null. Second, check that it has at least 1 character. Or maybe I want you to have, maybe it's a password. In that case, check that its length is at least 8. Dates and times. I'd like for you to look at this video. I'm not going to play it here for you, but it is a good video. It's one that I like. And Y2K was an example of actually it was an integer overflow. Well, we were treating our years as integers. And it was a decimal integer, and we had 2 decimal numbers in it. So I remember that starting. I remember back in 1970 or something, I was in the 60s. I was going to a computer class, and we had to drive all the way to Norman, Oklahoma to get to a computer. They had a computer at OU. So we drove from Lawton, Oklahoma to OU to use a computer. And I remember the professor talking, I was in high school then, and the professor was talking about, we're going to have trouble in 1999. Oh, yeah, okay, well, that's a long way away. I'd be old then. Then I remember hearing it again in 1980. It had gotten the name Y2K problem. People were still worried about it, but excuse me, I'm coughing time. Goodness. 1980, well, late 80s. We were worried about it, but I retired by then. So.
I was just going to add, in 1990, I took a COBOL class when I was in college. I was a sophomore, and the project we had to work on was to convert that 2-digit date into a 4-digit date for this exact problem we're talking about. Just get rid of that overflow.
It pointed out that it was a COBOL problem. COBOL was Common Business Oriented Language. It was a very, very popular language last century. The reason it was so popular for so long is engineering languages like Fortran the program is written for an ad hoc for the purpose. It stays around for a little while and then it goes away. In money, the money programs are going to stay around forever, and they did. And COBOL stored, let me see if I have it here. COBOL stored its dates. Oh, anyway, COBOL stored its dates as 2-digit month, 2-digit year, 2-digit month, 2-digit day, which was kind of inefficient because I don't need 2 digits. 2 digits would be 16 bits. I don't need 16 bits to represent 12 different months. I could do that in 4 bits. Yeah, 4 bits. And then I'd have a couple left over. So anyway, then everybody freaked out about it. And everybody ran out and bought ammunition and barricaded themselves in their house. You don't remember Y2K? Everybody freaked out. Yeah, we were the water wasn't gonna work. I thought water flowed downhill. It was real though. It was real, and we laughed because we were all worried about it, and nothing much happened. Nothing happened. Well, that's because we had our hand on the override switch right there. We were sitting there. All of the IT teams were on call that day. They would have every helpline was manned. There's a saying that dogs never get hit by the car they're chasing. If the dog's chasing your car, you're not going to hit that dog. they get clobbered by the one they never saw. Anyway. Mm-hmm. Yeah, and nothing much happened. But we were ready for it, and that's why nothing happened. Anyway, so after that, a bunch of COBOL programmers came back out of retirement and made lots of money fixing the problem. And so COBOL, that was the last of COBOL. Well, there's an old joke about that. It's called add 1 to COBOL. If the C and then C++ came along after C, C++ is C with 1 added to it. So the joke is that what came along after COBOL was called add 1 to COBOL. It's a joke on the COBOL syntax, which tends to be verbose. COBOL left, and it was taken over by other variants of C and Java. Well, yeah, COBOL was a good, perfectly good language. It was just verbose.
I would suspect the fact that I was 20 years old had something to do with it.
Well, anyway, fast and loose here. Essentially, we fixed a point in time, and we called that 0. And our 0 was Happy New Year 1970 is the date 0. And all dates are calculated from that. We just agreed on it. It records it as the number of clock ticks that have happened since then. If it's just a date, if it's just a day, I can tell. All I needed to know is how many days has it been since January 1st, 170. That's 0, and then 1, 2, 3, 4, 5, and so on. So we will never misinterpret the date. Now we will eventually overflow. Every integer will overflow. I suspect probably what we could do is shift it up a couple of hundred years. Well, yeah, we are a long ways away from running out of room there. So we will never misinterpret the date. We might have to use a lot of memory. So anyway, that's the way it's recommended. Yeah, pretty much. 1970 is the date. Yeah, the date 0. The 0 second is when the ball hits. 1970 is coming in. Okay. What is a tick? Some clocks tick faster than others, so I have to tell you what the clock tick is. So I give you a number, and I have to tell you in there how long does it tick. The typical clock tick is 100 milliseconds, I believe. So most of the time, the time is recorded in tenths of a second. 100 millisecond is 1/10 of a second. But you can override that. Most products use datetime. SQL Server uses datetime too, because, well, I think they've gone back to datetime, but I think the official one is we're supposed to be using datetime too. Now, I didn't know that. So we have date, we have time, and we have datetime. Date is just the date, no time. Time is just the time, no date. Date time is both. Okay, let me show you a couple of I've created me a little table here. I don't have any primary key or anything. No, you don't have to have a primary key. You can create a table without a primary key. I wasn't going to say that at the first of the class, but I'll say it now. Yeah, sometimes you do. It's not truly a database table because it doesn't have a primary key. But if I just want to demonstrate something, so my date is a date, my time is a time, my DT2 is a date time too. Just showing. Insert in here the values. This is the default format for time, for dates and or times in SQL. Year dash month in 2 digits dash day in 2 digits, which is, you might recall, has some of the same problems as the old format, but it is not stored like that. What happens is when it sees this format, when it sees this, it converts it into an integer starting at 1970 year, 0 day, and it converts it and does the calculation and puts it in there. And we've been using this up until now. It's okay. It's fine. I'm going to give you a different way to do it now.
Isn't that how Excel does calculations with dates? It converts those to a big fat number.
Sure. Mm-hmm.
That's what you're talking about.
Right, right. Mm-hmm. Excel converts them. Everything will do conversions. And that's about what we're getting ready to talk about is conversions from one to the other.
The software we use does that. It does the day two, like you're talking about.
Uh-huh.
And that is so annoying having that time. And I guess there's methods to get rid of that. But,
Sure. That's what we're going to talk about right now. Okay. If you have a date time, you have a date and a time. It stores the date, it stores the time. So if you're time stamping something as you put it in, you will get a date and a time stamp, probably down to the 10th of a second. So if you have a call center and people are putting in values that they're taking over the phone, you're probably okay if you just block them. Don't let 2 people put it in as exactly the same time. Just back them off a second. You'll probably have very few collisions if you're doing to the 10th of a second, because how many, I've got 10 people and they're each pressing enter at different times. They're probably not going to hit it right together. And if they do, they'll just get an error. And they'll say, what happened? And they'll just hit it again and everything will be fine. So some things I don't bother fixing. The where was I going with that? So we're letting the system convert it for us. We're just giving it to it as a string. So that's a string coming in. Notice it's a quoted string, and it's now I could convert that to a number and put it in there, because what is a time? A time is really a big integer data field. This is a time. That's 4:33 p.m. And this is the date and the time, formatted as the default. Okay. If I select it, I think I put some more stuff in there. Notice that top row first, that one is the one. And notice that it does have the zeros hanging off out there. So this is hours, minutes, seconds, and I think these would be milliseconds, microseconds. I can get it down mighty small time increments. Drop down. The old way we used to do that, we had something that we called set date format. And if I executed set date format, I was just practicing with it to see if I could get it to work, and it did not work on this version. So setting the date format, it says, okay, it executed, but then it doesn't do anything. It doesn't change the date format. So when I try to, I say in set date format month, day, year, and I try to insert in month, day, year, it worked, but then when I looked at it, it showed it to me the same way. I'm not sure what I was doing here. That looks the same as that one. For 2018, 4/5. I think I should see 2 of these rows, but I guess not. Oh, there it is down there. Let's see. Okay, questions at this point? That's the default way we insert dates. Now, that's fine up until now. That's all we've had. Now we're about to get something different. I'm going to go back to the page. And so this is page 5, probably one of the more important pages. In computer science, in any programming language, in any program, you will always have to convert back and forth between things of different types. For example, you will sometimes convert back and forth between character data and integer data. So I will change a string that goes like 1, 2, 3, quote 1, 2, 3, close quote, to the number 123. Okay. Casting it, yes. And there's also software routines that you can do where you read it one at a time and multiply and add and all that. And I will many times convert an integer to a character string for various reasons. Maybe I want to format it. Maybe I want to apply a particular font to it. A number doesn't have a font, but a character string does in most of them. So you will go back and forth. You'll go back between integers. I have an integer. I have 3. What is it? It's an integer. It's 3. Well, I want it to be a floating point number. So I will have to cast it to a floating point. Then it becomes 3.0. If I have a floating point, 3.5, for example, and I cast it to an integer, what do I get? 3.5, no, I'd have to get something that made sense. 35 would be way too big. I'd either get 3 or 4. I mean, it's between 3 and 4. It's halfway between 3 and 4. Well, what would I get, 3 or 4? And the answer is, if you're guessing, if you're betting, the answer is you have to try it and see. You will either get 3 or you will get 4, but 3.5 is not an integer. So you just have to cast it and then look at your value and say, oh, that's what it does. If you are betting, you will win most of the time by betting it's going to truncate, chop it down. So 3.9 will cast to 3 if you cast it as an int. That's a pretty good bet. There are those out there that will round it, but most of them won't. Now, there's 2 ways of converting data. Number 1 we talk about here is called the implicit conversion. For example, if I want to add 2 integers together, and so value 1 has the value character 2, the character 2. Value 2 is the integer 3. If I said add them together, value 1 plus value 2, what will I get? Why did I say 7? That doesn't make any sense. Two plus 3 I would probably see the integer value 5. I'll have to remember to make that change to the other copies. Not always, but not in all programming languages. But what's happening is that the database, at least, will try to figure out what you want to do. What is this moron trying to do? And they'll do that. So the database says, well, you're adding the character 2 to the number 3. Well, you probably want it to be a 2 plus 3. And 2 plus 3, as we all know, is 7. No, it isn't. Today it was. Okay, so that's called an implicit conversion. Implicit conversion is not good. Back up here a minute ago when we were working with these guys, this is an implicit conversion. That's a string. We're putting it into a date. It says, oh, well, I recognize it. By the way, most databases will take it in different formats. Excuse me. If I put it in this format, I was just testing, it will accept it in that format also. So it does implicit conversion. This is not this one. This one is the official format. They will all accept it in that format. But I was just testing it, would it accept it in a different format? And it does. Okay. So now the format for casting, when you mix data types such as int, varchar, or integer and float, particularly if you're going from float down to an integer, you should, server will always attempt to convert everything to the one that has the highest precedence. And I believe here I give you a link to the data precedence, which one is the highest and which one is the smallest. So it will try to convert up in here. I'll let you look at that. Why, when you try to use implicit conversion to add a number to a string, for example, if I tried to say hello plus 3, it wouldn't know what to do with that. So you get an error. This one, it would convert the string that had a 2 in it to the number 2. Let me go on here. All computer languages provide a way to change. I should have said in there an explicit way to change. And that is the term that you mentioned just a moment ago, cast. Okay? It doesn't change it. But what happens is it presents it to the assignment or whatever you're doing with it as something different. It doesn't change the thing that you're casting. In other words, if it's the string 1, 2, 3 and I cast that as an integer, my string is still 1, 2, 3. That didn't change, but I'm presenting it as an integer in the assignment or in the addition or multiplication or whatever I'm doing with it. So I'm using it, I'm saying, okay, this is a number, so use this as a number, but it stays a string in there. Okay, the syntax in SQL, all SQL is cast, then something to be cast, as, and then the type. So if it's varchar, you have to say how long do you want it. For example, here is the one that says cast 14.85 as an int. Okay, the value that I would select, this value is 14. Chops it off. Now I didn't change 14.85. That has to stay 14.85. Cast for.
If you cast it back, you're only going to get 14.
Yes.
Because you lost 85.
Yeah. Well, I've lost. I could put another. If I wrapped another cast around this. So if I didn't put it into a variable here or anything, but if I did, I could have. If I put that into a variable, cast it to an int, and then cast it back to a float, yes. Lots of times people will round by moving the decimal point over, adding 0.5, then casting to an integer, and then move the decimal point back with division. So they multiply by whatever power of 10 to get the decimal point over, add 0.5, it either carries or it doesn't, then truncate it to an integer, and then divide by 100 if it's money. So I'm trying to round to the nearest penny. So I multiply by 100, add 0.5, truncate to an integer, divide by 100, and now I have it rounded to the nearest penny. Works most of the time. Remember again that you have floating point problems in there. I don't know why I'm casting this thing with a decimal to float, but cast 5 as float, the result is 5.0. So by the way, this is known as a promotion. This one right here is known as a coercion. I've chopped it off, or a truncation. And so if I go from 5 to 5.0, that is a promotion. If I cast 15.6 as varchar, I end up with a string. In that string are 4 characters. 1 followed by a 5, followed by a point, followed by a 6. Okay. Select cast. This would be the same thing. Select cast 15.6, the string 15.15 decimal 6 as float. That has cast it. It now becomes the floating point value 15 6/10. And here is what happens. Cast as date time. Now, you can almost give it just about anything you want to there that it makes sense out of. So you could say April 4th, 2018, and it would probably be fine. If it isn't, this way always works. Okay. SQL Server has a fairly rich set. As for SQL Server does something that I really like. They have this convert. Now, convert is a nice one because convert lets me choose my format. And I don't know what's happened. This next page was blank. I guess I didn't get that page saved. I don't know what happened here. Let me talk a little bit about it. I'm going to go back over here to my SQL. Okay, cast. This one, I just plan. I don't know why I put null there. 5/32/2018 as date. What is 5/32? The 32nd of May. What about 5/32? Is that a valid date? Nope, there's no 32 on any month. There was a song once that says, "Save all your worrying for the 32nd of May." But there isn't one. So that one's going to give me an error. If I try to run that, it will give me an error. Now, SQL Server, so this bombs. This gives me an error. If I try to run this, boom, big error message. On the other hand, if I use, instead of cast, if I use TriCast. Now, I like TriCast. TriCast did not get included in the last SQL. So TriCast is the first one I'm going to really teach that is not pure SQL. Excuse me, I need a drink of water. I'm just going to keep going, and when I get to the end, I'm just going to quit. With TriCast, it tries to do it, but if it can't do it, it just gives you null. It doesn't barf. Now, if the first one, if I were running this as a script, when I hit this, my script would abort because I'd have an error. But if I hit this one, insert into date so when I try to insert this, I get the error message. But this one, when I try to execute this one, and I get, it worked. Did it insert the 32nd of May? No, it did not. Look what we got. It inserted a null row. Now, the null row might have caused a problem. In my case, if I were trying to put, if it were a primary key, of course, it wouldn't have worked. But that's a different issue. The cast, the try-cast worked in that it's trying to put in the 32nd of May, but that it can't, so it's null. Questions? Try-cast is nice because try it. If you can do it, do it. You could. Sure, you could. I don't know that I would just say you should know the difference between cast and try-cast. I wouldn't use it universally because it is a part of SQL Server, but not necessarily a part of Oracle SQL or something. So it's not, I'm not jumping up and down about it. I'm hoping it'll be adopted, yes. Because I think it's a very good, I give SQL Server kudos for doing that. Questions? The next one is also unique. SQL Server probably has a richer set of operators for handling character data, converting dates and stuff like that. By the way, try-cast would work if you tried to cast a string to an integer. So try-cast, and the string is 1, 2, 3, 4. It would cast that to 1,234. If you said try-cast hello to an integer, it would return null because it can't make any, it makes no sense. Okay, the next one. Convert. By the way, these are all fairly well, and I think better covered in the textbook than I've taken these out of the textbook, so I'm not. What is this? This is chapter 10. This module 8, chapter 10. Oh, is it chapter? No, module 10, chapter 8, isn't it? Yeah, you're right. You're right. Chapter 8. This is not an should not stand in place of chapter 8. Okay, with convert. Convert is mainly for dates. Also works well with integers and things like that. Let's see, did I? Let's see. I don't want to go through that. I'm looking for something easy. String code. I'm looking for the codes. There it is. Yeah. I recommend this site. I'll copy that and give it to you. Well, what did I do with it? I lost it. There it is. Okay. Now, these are the conversion. Convert is different from cast. Convert has a different syntax from cast. In the exercises, I ask you to do both cast and convert. Notice the different syntax that they have. Cast is pure SQL. Cast is from SQL, so remember the cast. Cast something, some field. So cast invoice date. So select something from invoices. Select what? Select cast invoice date as varchar. Okay. And then the date will show up as a varchar. Convert is a different thing. It's very similar, but it would be convert varchar to some length. You'd probably, I think if you don't say, I think it just figures it out for you. It's convert varchar invoice date. And the difference with convert is you have a style selector on it. Okay. Convert is not pure SQL. Convert is unique to SQL Server, but I think it's worth doing. Now, these style codes, got a whole bunch of them here. So, for example, if I want to see see it in the form of, if I want to see today's date in the form of April, or I believe it's APR, but there's one of them in there that will spell it APRIL for you, space 4, comma 2018, I would use the format code 107. If I wanted to see APR 4, comma 18, I would use the format code 7. So it's going to format it. So the thing of it is that using this convert, it converts it to a varchar. Let's look at how it works. Okay, here is varchar. Get date, by the way, is my way of doing a timestamp. Get date, open, close parentheses, gives me the server date and time. So if I want to timestamp something, when I put it in, I use get date. So I can insert that into a table, and that gives me a timestamp. So I'm saying convert, figure out take the day's date today, convert it to varchar, and apply 107. Execute. Notice it abbreviates it to APR. Can you read that okay? APR 5 2018. If I change it to just 7, get formatted as 7, now I just see it as 18. Now it's the same date. It's stored the same way. This is just how it's showing it to you. Select, okay, this is, apply that format to all of those things in date demo. I don't know exactly what I'm going to see, but there they are with that format applied to them. I think they were all today's date. A couple of them were null. Okay. This one just applies a 7. There are a whole bunch of different ones. For example, I can apply format 109. Format 109 is, I don't know why they're null. I guess because 109 is expecting there to be a time. Let's see, format 109. Yes, format 109 has a time and the others don't have a time.
Same method work in Visual Basic?
They have something like it. would work, Visual Basic and, so the question was, does that same method work in Visual Basic? I think so, just by accident, because Visual Basic and SQL Server are both Microsoft products. Therefore, they're pretty chummy. So it's very easy to open an SQL Server database from a Visual Basic program. Not so much Oracle. It can be done. I always have a lot of trouble with my connect strings. Well, I have done it, but it's just a lot of trouble. With SQL Server, it's very easy to open it under Microsoft Visual Basic. We don't teach Visual Basic because it is a proprietary language, but it's still an important one. And so on. So here are, I gave you this web page, the convert function. This is only SQL Server. So typically you will not expect to see this on a test, just because I want this class to be about pure SQL, not about SQL Server. But when I think something is really good and I really like it about SQL Server, I will cover it. Convert. Okay, convert and cast have different formats. It's shown clearly in the textbook. So convert something to data type. Excuse me, backwards. Forget what I just said. Cast something, some variable, as some data type. Convert data type, comma, value, comma, format code. So convert to an integer, 25.65, 25. So it works a lot like cast, but the nice thing about it is that it says here, see also the cast. The only time I would use the convert is to get that style, and there are lots of different styles. Converting float to real, converting money to characters, whether you want commas in it or not, and it's handy. It's worth looking at that website and playing with it. I give you on the exercises, there's one that I asked you to do, cast and convert in the same one. I'm really not trying to be tricky. It is really that easy. I think that's my last slide. I thought I had something here for try convert. I guess I need to write that page. There's the quiz. Exercises. This one's only worth 20 points. It's not a difficult set of exercises. 1, 2, I think there's only 2 questions, and I'm asking you to do convert and cast. Pay attention to this quiz. I do take a couple of test questions from the quiz on this one. So don't just, your objective on this quiz is to learn the questions, not just get through it. Some of them you just get through. This is one that you should probably pay attention to. Next test is coming up. We need to have it. We're a little bit behind. Let's put it this way, not next week, but I have a feeling it'll be week after. Okay. 2, well, 3 counting the final. Okay. I'm going to discuss the final in detail. So what we do is, if you have done well on both of your tests and everything is caught up, then you get to talk to me. Know what I mean? I have a conversation with people about where they're at and what they need to do on the final. And, you know, for people who have near perfect average, there's no point in fooling with the final. But I'm not supposed to do that.
You're the boss.
Yeah, well, kind of. I mean, and insofar as I don't come to anybody's attention, yes. Okay, that is going to, I don't think I have. Okay. Well, I'm going to go ahead and end the recording at this time.